This video will be about SolidWorks. Specifically, it will be covering how to download SolidWorks, how to install SolidWorks, while probably licensing everything, and finally, how to use SolidWorks. Just to give a bit of introduction, right now in the design process within RAD, we've already gone over how to use OpenRocket to generate a two-dimensional rocket model. And now we want to bring it into the third dimension. That's essentially the point of this video. All right. By the way, at this week's RAD meeting, this is exactly the stuff we're going to be doing. So when you walk into the meeting this Friday, you will have the opportunity to select one of three design areas to work on. That being, the first area is the rocket frame, body, nose cone, and fins all combined. The second area is the motor itself, the motor mount, and just the motor retainer system. And then the third area is the ejection system. So out of those three areas, the ejection system is the only one that's not going to be using SolidWorks. The other two areas, well, okay, sorry. The ejection system will be using SolidWorks later, not this meeting. This week's meeting, the other two areas will definitely be using SolidWorks, especially the one with the rocket frame, nose cone, and fins. The motor mount stuff will also be using SolidWorks, and we will get into that right now. So we're all starting here right now at the same point, which is an open rocket design. Okay, so we're gonna get this into 3D, but what does that actually mean? All right, this design, this simulator, this program, OpenRocket, just gives you a 2D display, but there is an option within this tool to actually show you a 3D rendering of the rocket. Putting that in SolidWorks is necessary still, because not only does SolidWorks give a 3D rendering, but also a model that can give accurate mass and different structural properties. But the 3D rendering gives you a good hint as to what this rocket actually looks like. But basically, this rocket is actually a cylinder. The nose cone is a cylindrical, well, it's a conical shape, right? So if we look at it from the side view, we're gonna have circular cross sections going all the way through the rocket. And then the fins are flat sheets, but they're circular. They're placed in circular symmetry around the cylindrical body. So we're going to be getting into those three parts in this video, which is the fins, the body tube, and the nose cone. And we'll show you how to make all of those in SolidWorks. But first, we need to do the installation and the downloading of the software itself. Okay, now let's walk through how to download, install, and start using SolidWorks. The first thing you should know about SolidWorks, if you haven't downloaded yet, is it's a huge file size. So it's maybe like, just to be safe, have 50 gigabytes free. Okay, this is a massive, massive file size. If you don't have like 50 gigabytes free on your computer, this might not be the best idea to try to download. You can do certain things like when you install SolidWorks, it will install some add-ons that you can optionally deselect, which is fine for this project. You can deselect those, but it'll still be pretty big. The base software is probably over 10 gigabytes. I'm not sure exactly of the size, but that should be, it should even tell you in the installation wizard once you get to that point. But just a heads up that to safely just follow these or to safely download SolidWorks and all the add-ons, you want like 50 gigabytes free storage. So okay, let's get into actually how to do this. So to get to this page that I'm on right now, what you're going to want to do is Google SolidWorks student download, or I've Googled it here, and then click on the second link that says community download, and that'll take you to the right page. So once you're at this page, by the way, this is a completely free installation of SolidWorks. It's the student version, and since we're students and we're technically part of a student organization, UTD has agreed to contract free. Basically, we get free licenses, so do not pay for SolidWorks. All you have to do is enter your first and last name, your NetID email. This is important. Please make sure to enter your NetID email that at ut.edu. This is how they verify you're a student. And then you can select student optionally. Don't select student team. I don't know why, but just select student, not student team. Okay. And then click the academic version 2021-2022, and then click yes here. That's going to be what causes them to prompt for the serial number, which I'll explain the serial number, but we have them. So I'll tell you the serial number in a bit. After you've filled all these out, exactly like I said, click request download. Request download, I'm not going to click it, but request download will start giving you the download sort of wizard where it asks you what things you want to download and all that stuff. This is where you can check or uncheck the certain add-ons, but you definitely make sure you want just the base software, which is SolidWorks 2021, 2022. It might be academic version, but yeah. And then it'll also prompt you for the serial number at some point, in which point you'll have to put in the serial number. And here is the serial number. Serial number is this whole thing, 9020, and then a bunch of stuff. Put that exactly how it is. And yeah, so then that's pretty much how you install it. Once you get to that point, it'll give you the installation wizard. You can choose what folder to put everything in. I like to put my stuff on the I like to put my stuff on the uh okay, so I like to put my stuff on here. So here's all my SolidWorks on the desktop is what I'm trying to say. So yeah, I put my stuff on the desktop, but you can put it wherever you want. So yeah, that's up to you. But that's once you've done all of that, if you still can't access SolidWorks or it doesn't or some step along the process doesn't work, well, feel free to ask questions to me personally or anybody that's a RAD leader, and we'll try to help. Okay, so now we're in SolidWorks, and we're gonna start building the rocket. So SolidWorks is a very big program. It has a very complicated um, use, like it's very complicated to use, and there's a whole course on using CAD software, which SolidWorks is a type of CAD software, is a certain company that makes it. So this tutorial is going to be covering only how to build this rocket. There's a lot of concepts we're going to be skimming over somewhat or downright just not talking about. But we're going to cover the basics that you'll need to use to adapt this tutorial to your own rocket design. You'll be changing dimensions, you'll be changing possibly the certain shapes that you use, but it'll be very similar to what we do here. So without further ado, let's get into it. First thing we're going to do is the fins. So if I go to my open rocket, I want to show you what the fins are supposed to look like. So, okay, and again, the dimensions, the shapes of everything might be different. Plus, this open rocket design is not quite finished, but it is the one I was working on a few weeks ago. So, and this is what the fin looks like. All right, and we're going to be making this shape in SolidWorks, first of all, and I'll show you how to do that. So I'm going to be going back and forth between these two tabs throughout the process. First thing you want to do, we have the blank SolidWorks screen. You can get rid of this thing or just keep it there because I don't know how to get rid of it apparently. But what you're going to want to do is File, New Part. Okay. Now we click on Part because what we have in SolidWorks is parts and assemblies. So you can make an individual part. Let's say you're making a car. You might make the frame for the tire as one part, and then you make the rubber part of the tire as another part, and then you make the axle as a third part, and then you you can assemble all of those within an assembly where different parts can come together in the assembly and be fixed to each other in different ways. Um, that's how SolidWorks is. So right now we're just going to do the fin, which is a part of the rocket. So we go to part. Now what we want to do is I'm going to show you how to all the details in a bit, but I'm going to click on extruded boss slash base, and I'll explain what that does in a little bit. Don't worry about extruded boss slash base right now, just click on it, and then click top plane. You'll see front, right, and top plane. You can technically click on any of them, but I do top plane for certain there's a certain criteria that I use to choose which plane, but yeah. All right, and we're gonna make a sketch now. So you see, it automatically, once you click top plane, it automatically takes you to this sketch tab. And that's important because we need a sketch as the basis for any type of part we're gonna make. A sketch is the general outline. And if we look at the fin, I'm gonna go back to this tab now. We see the general outline is like this trapezoid shape, but then it goes down a little bit in a rectangle and it connects. So let's make that. And we're not going to worry about the dimensions just yet. I'll show you how to do dimensions a little bit after this. But first, I'm just going to start here. I'm just going to start making lines. So you click on this line tool. There's some options within it, but we want to click on just the line part. And we see all these options on the left. We don't need to change any of that. So let's just start. Don't click the check mark, don't click the X mark, don't do anything over here yet. We're just going to start at the origin, left click, and then you drag. You're just moving the mouse now, and I can select where the endpoint is, and left click again for the endpoint. And you see it's now made a line. And now I didn't have to click again. It's automatically going to make me another line. I'm just dragging the mouse to another point and left click again. Drag it to another point, left click again. You see the first line I made was diagonal. I did that intentionally. SolidWorks will try to snap it to be horizontal or vertical. If you want it to, it'll automatically snap to the horizontal vertical pretty easily. So you see I made this second line is perfectly horizontal and this is perfectly vertical. All right, so now I'm going to move it to this point and click again, 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 and then make sure you click on the same point you started at to close off the shape. And you'll see something happen when I click this last one. The shape turns a different color. It's now gray. Gray means it's a closed contour. It's a closed shape, which is good. You need a closed shape to be able to use the next feature I'm going to get into properly. All right. But before we do that, we need to properly dimension all of this. I just randomly clicked the general shape, but now we're going to do dimensions. So let's look at what I had in my OpenRocket design, and I'm going to look at the Edit tab on trapezoidal fin set to get those dimensions. So we see that there's 4 fins. The root chord is 2 inches. Okay, the root chord is the distance from it's essentially the widest width of the it's the distance from I'll show you here. It's a distance from this point to this point. That's 2 inches. So, all right, I'm gonna click check to get out of here. You can also click escape. But I'm gonna do smart dimension. Now, smart dimension, you can click on a line, it'll give you the dimension, and you can change the length of lines that way. I want the length from this point to this point. Now, smart dimensions is pretty smart. All I have to do if I want the dimension from this point to this point is click on one point, then click on the other point, and there it is. Now I click again because this is moving where I want to display the dimension, so I want to move it out so it's not cluttering. Then I click. Now it's going to let me modify it, so I want to change that to 2. Okay, and you see it changed it to 2. Um, Tip chord, that's the length of the top line, so we're going to go ahead and dimension that. So we can just click on the line if it's a straight line, and it'll just know it wants to dimension that. So we click on tip chord and make it 1. Click enter to set the dimension. All right, now you'll notice a lot of green icons. These green icons are called relations, and they're pieces of geometric information that tell SolidWorks how to make like certain things. So SolidWorks has this vertical line right here. It's called vertical line 3. So this line is called line 3 and it's vertical. And SolidWorks will keep it vertical because there's this green thing next to it telling it to be vertical. You'll see other types of constraints. This means coincident. It refers to something that's on the same point. It's essentially what's keeping this point connected to both lines. Okay, this gets a little bit involved, but yeah, these green boxes are important, and we'll be adding some of them in later parts. All right, so let's finish the dimensions. Let's see if there's any other important ones. The height is 1.5 inches. All right, the height refers to everything except this bottom tab. Oops, I didn't. Everything except this bottom tab. So the height is from this point to this point, and it's 1.5. So let's make sure SolidWorks knows it's 1.5. And click enter, and it makes it 1.5. And I think this is supposed to be vertical. That's right. This is horizontal. If you need to change some of this, there's ways to do it, but this is my simple build for now, so I'm going to leave it like this. And let's make the tab. So the tab is actually, let's see, fin tabs, 1 inch in length. It's 0.512 in height, and the tab position is 0 relative to the root chord midpoint. So let's try to transfer all of that information. So the height was 0.512. Okay, wait. Oh, it's clicking on the midpoint. I want to click on the, oh, I didn't have this selected. Wait. All right, select smart dimension. Sometimes you have to select out of something. Anyway, so 0.512, and it rounds it. It just rounds it on the display. It keeps that information in there. This is actually 0.512. It's just not displaying all of it. And we saw the tab length was 1, so that's this. Make it 1. And now how do we make sure the tab is centered? Okay, if I get out of Smart Dimension, we can still drag this around, so it's not necessarily centered. All right, but there's one sure way to make this centered. We're going to use a relation, and we're going to make sure that this length is equal to this length, and that will compute everything automatically. So I'm going to click on this drop down and click Add Relation, and this is where those green boxes come in. When we add relations, we're going to select those, add some more of those green boxes to stuff. Think of them as constraints. So the program is doing math to compute what the actual shape and dimensions of everything exactly are. So the first thing we see is there's selected entities. So we're going to delete line 5. That's not something we wanted to select. I think that was this one. What I want to do is select this line and this line. It's called line 4 and line 8. Okay, whatever. And then I'm going to click equal, and what that does is make them equal length. Okay, so now this line and this line are equal length, and there's nothing anything can do about that to change it. What that means is that this is now centered. And notice how I was able to drag it around before? I can't anymore because SolidWorks is constraining it. These are now equal. There's nothing else I need on this shape. It's completely done, so I'm going to click exit. And it takes me to this screen. This is where, if you remember from the beginning, the boss slash extrude come from. Extruding is taking a shape and pulling it into the third dimension with a vertical, just a straight up height. So this is just basically where we put the height. So I'm gonna put 0.1 inches because why not? No, I'll put 0.25. I'll put 0.2 inches. And it's gonna be in inches because the whole thing is in inches, so yeah. It's too thick. I need it to be thinner. I don't like that. 0.1. I'm just doing this really approximately for now. But yeah, now we have the fin. All right, one last thing. IPS means inch pound second. Make sure it's in there at first. It should be by default. All right, so now we're gonna save. So wherever you want to save it, you can. So you click Save As and save the part bin. And I don't really want to save it there. I'm just gonna save it on my desktop. So there we go. And now it's saved.
Hello everyone, my name is Dan and I'm a CAD workshop leader for AIAA. So today I'm going to be walking you through how to create the body tube and the nose cone in SolidWorks for the RAD model rocket. The first thing you want to do is go to this file, new, and create a new part. You can see I've already done that up here. And you want to make sure that your units in the bottom right are in inch pound second. So I've got that selected as well. Now we're going to create a two-dimensional cross-section of our body tube and then extrude it into a third dimension to create that 3D shape. It doesn't really matter which plane we start on, but for this model I'm going to click on my right plane and I'm going to right click, click sketch, and we'll draw the cross-section on the right plane because it'll make it easier when we're assembling our parts later with a nose cone. So I'll go up to the sketch tab that was just selected and go to the circle tool, and I'm going to create this circle centered at the origin, this red section right here. You can see that yellow box pops up that tells me it's coincident with the origin. I don't want to put it out here, otherwise I'll have to dimension that center. So let's delete that and put our circle right on the origin. Doesn't really matter the radius because now we are going to use this smart dimension tool to create this outer circle radius or diameter. I'm going to set this outer diameter as 2.8 inches, and I'm going to create another circle using the sketch tab at the origin. Hit escape, and I'm going to go to smart dimension and make this circle 2.6 inches in diameter. So this inner diameter will allow the nose cone to slide in. Now I can exit the sketch, go to features and extruded boss base, and right away it automatically selects my sketch that I created. But if not, you can go to the selected contours and select the sketch manually. And in this direction, you want to hit blind and set it to 28 inches in length. So now we'll hit OK. And now we have the three-dimensional shape of this body tube. So let's go ahead and file, save, give it a name. And then once you're done with that, we can go to File and New and create a new part for the nose cone. And for this one, we are actually going to do a revolution instead of an extrude. So a revolved boss/base. For this one, we need a two-dimensional sketch section plus an axis of revolution, and it will create a revolved part around that axis. So let's go ahead onto our front plane and right click and press sketch. Also take note that your units are in inches as well. So go back to that front plane, hit sketch, and now we're going to construct the cross section, the 2D cross section of a part of the nose cone. And once we construct that cross section, we will revolve it around a center line. So the first thing is we'll create a vertical line up from the origin. Let's just say for this one, it's about 1.4 inches, for example. Then we need a horizontal line 6 inches from the origin on the left. So notice how when I'm dragging this horizontal line, I have this yellow and black box, which tells me that the line is horizontal. So these are called relations, and it will avoid me having to dimension the line more than I need to. If I, for example, put it right here, you'll see that the line is not fully defined, and actually I can kind of drag it around here. It's still blue. If I delete this line and I actually create it with that yellow box appearing, the only thing I need to dimension is this endpoint. Actually, we know that the line is horizontal now and it can only move along this axis. If for some reason you can't get that relation to appear right away and you accidentally make the line offset, what you can do is click on that line, go over to the Add Relations box on the left, and click horizontal to avoid having to dimension the endpoint more than you need to. Now go over to the Smart Dimension tool and let's dimension this line as 6 inches. Okay, so from the top point of this vertical line that we just created, let's have a horizontal line that goes left by 0.5 inches. Let's make that, ensure that that has the horizontal relation attached to it. Let's make it 0.5. So now we have these two open endpoints which we're going to connect with a circular arc. We can see we have a 3-point arc here in the sketch tool. So let's use this one. We'll have one point right here on this endpoint, another point right here, and we can place this other point wherever. So in order to make this fully constrained, we're going to have to click on the curve that we just made and then press Control left click on this straight segment, and let's add a tangent relation. So you'll see now that this surface is smooth, it's flush with the straight line that we made, and we don't need any more dimensions or anything like that because we've applied the tangent relation. So now SolidWorks knows how the curve is going to look. So we also need another section that will connect into the body tube. So let's start on this rightmost surface and create a line that will go out to the right, back down, and then back all the way to the left. So the dimensions we need for this, the topmost point is 1.3 inches from the origin. The length of this horizontal line should be 1 inch. and the thickness or the depth that it goes down is 0.1 inches. So you'll see in a bit how this will extrude into, or how this will revolve into the final part. But notice that it's kind of transparent here. We want it to be all grayed out, all one connected sketch. So we're going to go to the Trim Entities tool, and we are going to cut these lines that we don't need. So I'm going to cut this line right here that was preventing this from being one solid sketch. So now we can create our axis of revolution, which means I'm going to go to line, I'm going to click the drop down arrow and pick center line. And as long as your line is anywhere on this horizontal axis, then it should be good to rotate. So I'm just going to click, make sure I have the horizontal relation enabled. Looks like this line is already horizontal. And instead of dimensioning it, I'm just going to make it an infinite length line. Now if I exit my sketch, I can go to Features and go to the Revolved Boss/Base. So clicking on this Revolve tool, it automatically selected my sketch and my axis of revolution. So the axis is going to be that center line that we created, and the selected contour is going to be this sketch that we just created. And you could see it's taking that sketch and it's revolving it around this line until we get to the final shape, the full 360-degree revolution. Okay, so now I can hit check on that revolve, and now I have the completed nose cone. So I can later assemble this into the body tube, and I can also modify the inside of this nose cone so that it's maybe hollow when I'm 3D printing it. So let's save that. And that's how you construct the body tube and the nose cone for the model rocket.
Right. This just about concludes the first SolidWorks tutorial. We'll have more of these coming out to cover a bit more advanced topics. Um, so thank you for watching. I hope you learned a lot. I hope you learned at least something. And one last thing, and I have this slide here just to bring the point home. Okay. Um, so this tutorial is for my rocket that I sort of built on my own. You're going to be building your own rocket, changing the dimensions, and doing different stuff like that. Everything what I said is applicable, but that dimension section where I put all that stuff in, that's going to be different for you. And yeah, there's a few requirements to actually go by though. So on the document that was given in the announcement, there are some required dimensions, okay? But we're not going to think about some of those things for the time being, because this is the first week of design. We want to get everybody like some of you probably have never used SolidWorks before, and this is a bit advanced for right now to have everything crammed into 1 week, especially since the meeting's in 3 days. But yeah, another thing, just preparation we would recommend. Just practicing the concepts we said here, just 10 minutes. So yeah, that's pretty much it. Thanks for watching, and we'll see you at the meeting.